time for me to speak in front of so many people, so I'm quite nervous at the moment. I'm a not native English speaker, so I try to do my best. One final thing before I start with my presentation is, if you have any questions during my presentation, please feel free to interrupt me at any time, and I'll try to give you an answer. So, is it okay if I speak? Is it from the loudness? Okay. So, my talk is about my latest project called Ruby.js, which is a Ruby to JavaScript compiler. And what I tried is to do it as efficient as possible, whatever efficient means. So there are two extremes. The one extreme is to implement a full-featured JavaScript Ruby interpreter inside of JavaScript. I would have called it JS Ruby. What JRuby is for Java would have been JS Ruby for JavaScript. So this is, of course, you can run everything of Ruby inside, but it would be terrible slow, I think. So the other extreme would have been to just take the syntax of Ruby and translate it straightforward towards JavaScript, ignoring the fact that we would lose a lot of Ruby semantics. So what I tried is to find the way in between, to on one hand keep the beauty of Ruby, and on the other hand to make it as efficient as possible. So at first I would like to spend a few words on why I implemented Ruby.js at all. What were the reasons I had? And then I will go in the second part through the details, what were difficulties for translating from Ruby to JavaScript, the design decisions I had to make, and then at the end I will talk a little bit about Ruby Web Toolkit, which is it's a port of Google Web Toolkit to Ruby.js, but it's not complete at the moment. So, but before I go into the short analysis why, for me, JavaScript wasn't the right solution, I would like to give you a small example just to get a brief idea of what I'm talking about at all. So this is just a small Hello World example. I'm actually using the DOM document object model from the Ruby Web Toolkit, and all it does, well, this Ruby file will then simply compiled using this command to the hv.js file, and you can simply include it inside the HTML file, and when you click on the anchor tag, it will show Hello World. Then we see here what is actually generated for the self.main method. It's, well, one thing you see is that the names are not the same in the generated JavaScript code. So all the local variable names are changed, and the method names are changed as well. I do this for a reason, mostly to reduce the code size and to obfuscate the whole source code. But we'll take a look at it later. Then a second example is a little bit more complex. I intended to give a demo, but, well, I don't do it at the moment now. So what it does is when you click on this anchor tag from the slide before, it will trigger a asynchronous request to the server side, and then the server side will send JSON encoded data, and I just unparse the JSON and have an object. This is all then on the JavaScript side, and I call inspect like we do in Ruby as well, and will give me the same result as I would do exactly the same code on the Ruby side. So spec is actually implemented in JavaScript, but it will give the same results. So now I would like to go a little bit through the why I didn't want to stick with JavaScript. So everything I talk about is about applications, not about small scripts written in JavaScript. So applications are, for example, something like Gmail or Google Maps. So if you want to hide an element or to submit a form using Ajax, then I think you should stick to Prototype or Scriptaculous or jQuery. But what I'm talking about is about applications consisting of thousands lines of code, maybe. So one reason is that for me personally, it turned out that JavaScript is a lot more error-prone. And one example is that you have to declare local variables. You don't have to do this in Ruby. If you forget it, they will become global variables. Block argument. So yeah, you see the examples here. This one is in Ruby, this maps to this one. So in JavaScript, you can omit the last values, which are then undefined. Another solution is to choose a variadic call convention, which is given here. If I have a method in Ruby which has no arguments, I will simply convert it to a function with no arguments in JavaScript. If it has an optional block argument, I will convert it to a function with one argument. If I have a method with 2 arguments, I will convert it to a method or a function with 3 arguments. And here you see the first argument is always the block argument. And then all the other arguments will follow. I'm doing this because of using catch-all arguments. So if I would put the block argument behind, I couldn't distinguish them from a regular argument. So this is the code equivalent to this. This is all done by the compiler. So which one is now better? So the fixed arity call convention requires to pass always an array, which allocates memory and as such is quite expensive. And it's actually around 2 times slower than going the variadic call convention way, using the JavaScript arguments special value. So now to the seventh beauty of Ruby, that of we have general purpose hashes in Ruby, and we don't have them in JavaScript, or JavaScript uses objects as hashes. I think there's no implementation of hashes, of real hashes inside of JavaScript. The problem here is that those objects in JavaScript, they only take strings as keys. And in Ruby, we can use any value as a key. So you see here that actually, if this would be Ruby, then here we would have the value 4, but in JavaScript, we get the value 5, because the integer 1 is converted to a string and will override the other element. One solution could be to map the Ruby hash to an object in JavaScript. A second solution could be that we implement our own hash class in JavaScript. So mapping a hash to an object has the disadvantage that it will not behave the same as Ruby. We have only strings as keys. And a second disadvantage is that everything inherits in JavaScript from object. And so everything in Ruby.js would inherit the methods from class hash. And that's definitely not what we want. So implementing our custom hash class in JavaScript is of course slower, takes more memory, but it is general purpose. And here I've chosen this way because I didn't want to sacrifice the Ruby's beauty here. Then another beauty, or maybe not beauty of Ruby, is that strings are mutable and they are not in JavaScript. Though we could wrap strings inside of custom objects as we do with hashes, but we could also map them directly to immutable strings. And well, you already know the answer. Here I'm going the efficient way, because strings are all over the whole program, and it would give a huge memory overhead to wrap every string inside an object in JavaScript. The disadvantage, what we have here by using immutable strings, is that we can no longer use the destructive methods in Ruby. So, at the beginning I've talked already about method missing. So this is again not found in JavaScript. We've also seen a possible solution by using dispatch functions. Well, but this turned out to be too slow. And so the second solution here is that we already know all the call methods because we are using static Ruby. So I can simply assign every object a method stub if it doesn't have this method. So whenever you call a method that is in Ruby not defined for this object, this method stub would be called instead. Now to the last beauty of Ruby. Well, it's not actually a beauty. That of Ruby is a quite complex language. I remember a talk from Matsu about human programming, and he said that human loves complex and human hates complex, and the same, human loves simplicity and human hates simplicity. So what does complex mean? I think for the user, Ruby is not that complex at all. But for the implementer, it's quite complex. For example, meta classes in Ruby are quite complicated. So if you have any questions about meta classes, I don't know if I want to answer them here. Then multiple assignment as example. Well, then some semantics differences in semantics from yield and block call? Or do you know the difference between if I call a method with a block and return occurs versus if I do a break? I didn't know about the difference before I implemented Ruby.js. But the good thing is that, well, the solution is to just do it. And yeah, I just did it with Ruby.js. Okay, any questions? Yes?
For the ifs inside of assignments, why not just wrap it in an anonymous function and execute?
Yes, but that's quite inefficient.
It's not. I just profiled in Firefox, and it seems it's faster. In Firefox, maybe IE has like a less.
To use, you mean the if statement?
Yeah, just put the if statement, like return, instead of just like, so where you would just say whatever, you'd say return whatever. You wrap it inside an anonymous function and execute. It seemed like, I also thought.
But do you know the memory overhead?
I can't easily detect that from Firefox.
But I'll take a look at it. Thanks. So now about applications. So there's an ongoing effort to port Google Web Toolkit to Ruby.js. Everyone knows Google Web Toolkit. So this is actually a Java to JavaScript compiler, and it also includes a widget library. So I've ported most of the core classes like the document object model, events, Ajax code, the base object of everything in Google Web Toolkit called user interface object, then a widget and a label. I don't know, but I guess it's around 30% done. So what is the difference between the two? The one is, of course, in Ruby or Ruby.js, the other is in Java. One uses dynamic typing and the other one uses static typing. Of course, Ruby.js generates less performant code, and Google Web Toolkit is probably much more mature than Ruby.js. But Ruby.js has a big advantage, and that is we can use a lot of meta-programming here. And, well, if you have already an application written, a server-side application written in Ruby, I don't think you would like to use Java on the client side, especially because Google Web Toolkit is a quite complex framework. So an advantage could be to have the same code on the client side and on the server side. And yeah, for example, validation code, you could, in active records, have a specific validation code and then simply compile it to JavaScript and use it there. So I would like to talk about how browser-specific code is handled in Google Web Toolkit and in Ruby Web Toolkit. So in Ruby we have open classes, and this is actually a very good thing. So in Google Web Toolkit, you see that it involves quite a lot of files here. We have at first the external interface, what the user will call. It's called dom.java. Then we have an implementation-specific interface. And then we have DOM, the standard or default implementation, which should run on every browser, which is DOM implementation standard. And this DOM implementation standard inherits from or implements DOM implementation here. And then we have for each browser a separate file, for example, DOM implementation Opera, which then inherits from DOM implementation standard. So it's quite complex. Yeah, in Ruby it's a lot of much simpler here. We've simply a dom.rb, which includes on the one hand, the external interface, but as well includes the default implementation. So we don't need an internal implementation interface. And then we have for each browser a specific file which simply overrides those methods that have a different behavior in the browser. And now I want to talk about how this is used. So you usually will require this file, and then you can, on the command line, you can specify for which browser you want to generate code. So you can pass a platform option, for example, -- platform Opera, and the output will contain only the code that is specific for Opera. So the require will at first load the dom.rb file, and then depending on the platform for which it is compiled, it will load this file as well. So this is a very, very beautiful way to implement browser-specific code. So I think I'm now at the end. Yeah, thank you very much. So do you have any further questions? Yes, please.
What about testing?
Yes, that's a very good, yes, thanks for this question. So I have a lot of test cases actually, but I don't use something like test unit or behavior-driven development. What I do is I have just Ruby code with all the Ruby, like I'm testing for exception handling. I simply print out on standard output the results, and then I run this code inside of Ruby, and then I compile the same Ruby file, the exactly same Ruby file to JavaScript, and run the same inside of a JavaScript browser or on the command line. I tested it in every possible browser, and then simply I compare the both results. And if they match, then everything's fine. So this is how I test. Yes?
Components of the GWT framework is a plugin for your web browser that allows you to interactively test your web page as you're designing it, and have the Java, in that case, backend, execute all the code that you're interacting with on the browser. Do you have plans for a similar feature for RWT?
Well, I could imagine to implement all this, for example, the DOM class to write a proxy, and to have an HTML file loaded with an HTML parser in Ruby, and then to access the HTML tree all in Ruby, so we can test the, not in JavaScript, but we can run the whole application inside of Ruby. But well, if I would have enough time, I would do it, but maybe someone else would like to do it. Or maybe someone would like to pay me for it, so. Yes. So, yes, once again?
I'm not sure exactly how this works, but probably fairly simple. Like to go into IRB, type stuff, and then proxy it into Firebug's console. Like to take the Ruby that you typed into IRB, compile it on the fly into some JavaScript, and then run it in Firebug. Like
yeah, but I'm actually compiling the whole program.
Right.
So and not just small snippets. Because, yeah, I could do this, but yeah.
Because you can get a parse tree off a small snippet.
Yeah. But if you call them methods inside of the snippet, those methods must be compiled as well. So this is maybe a problem. Okay. Yes?
You mentioned that the compiler obfuscates the code a bit.
Yes.
How do you do debugging then?
I have an option to turn off name mangling. But yes, I don't debug so much because I'm using Ruby.js. In JavaScript, you would need a debugger. But this is a good point because that's quite hard to debug. Right. Okay. Any further questions? Yes?
Do you have any applications built on that today?
If I have application using Ruby.js, not yet actually. Only there's the small examples shown at the beginning. So, yeah. Okay. Any further questions?
Yeah. Is it possible to make some prettier way to access the DOM? I mean, I haven't got any ideas.
You mean instead of calling dom dot all the
Yeah.
time? Yes, it is. The problem is that those not objects from the browser are not in every browser a JavaScript object. So you can't attach methods to it. But what I could do is to wrap them inside of a JavaScript object. But this again takes more memory, is slower. So I was just porting how Google did it because it's the most efficient way to do. But yes, it's definitely doable. Yes, like jQuery, for example. Prototype, I think, does it as well. Yes. Any further questions?
Do you have a URL for the project?
Oh, okay. Yes. You can take a look at Ruby talk about my announcement, or I can try to write it down here. I definitely should open up a Ruby Forge project for it. Oh, I think it's too big. So, this is, if you want to download it, the best way to do it is to use the Mercurial software control system. But you can also just open up in the browser and see the README file and all this stuff. You can even try out the test cases. Just click on the file and you see that they run inside your browser. Yeah. And you can also write me an email if you're interested. Yes. Okay, any further questions? I don't know if we have any time. I think there was a question behind, or no? Someone? Okay, thank you again.